In the vast, silent expanse of a universe, we are arguably the most curious inhabitants. Yet we often wonder if we're truly alone in this cosmic story. Are we the first spark of intelligence to emerge from the chaos, or just a fleeting blink in the grand timeline of life? What if our moment here is part of something bigger, a repeat, a cycle, or perhaps a rare anomaly? As we ponder our origins and future, we're forced to ask, are we the pioneers shaping what's to come, or the last echoes of a fleeting chapter in cosmic evolution? Stay tuned, because unraveling this mystery could redefine everything we believe about ourselves, our place in the universe, and what it truly means to be intelligent. The search for extraterrestrial intelligence, SETI, and human self-awareness. Humans have long pondered whether we are alone in the universe or simply the latest in a long line of intelligent civilizations that have risen and fallen, if such civilizations exist at all. SETI, the search for extraterrestrial intelligence, embodies our collective curiosity and hope that somewhere amidst the vast cosmic ocean, signals or signs of other beings may be waiting for discovery. Technological advances have allowed scientists to scan distant stars and listen for the faint whispers of alien civilizations. Yet the silence so far remains profound and deafening. This ongoing search forces us to confront fundamental questions about life. Is intelligence a rare cosmic fluke or a self-perpetuating phenomenon? And more intriguingly, what does it say about us that we are still listening but have yet to hear anything definitive? Alongside this scientific pursuit lies a deeper philosophical inquiry. What does self-awareness mean for a species? Human consciousness stretches beyond mere survival. It involves reflection, morality, and a sense of purpose rooted in an understanding of our place in the universe. As we develop technologies that could, in theory, detect other intelligences, we also examine our own capacity for introspection. Could our self-awareness be a trigger for cosmic significance or, conversely, our greatest vulnerability? If intelligent life tends to self-destruct or retreat into isolation, are we any different? Our ability to contemplate the universe may be a product of evolution, an outcome of complex neurological processes, yet it also grants us the unique power to influence our destiny and perhaps, one day, forge genuine contact. The paradox lies in recognizing that the very act of searching might be a sign of our uniqueness or, alternatively, a sign of our temporary survival, an anomaly in the broader cosmic timeline. It's possible that civilizations engage in a cosmic game of hide and seek, or simply never reach an advanced enough stage to broadcast detectable signals. Our self-awareness adds a layer of vulnerability. It amplifies our doubts while fueling our hope. Are we the first truly intelligent species, or are we simply the latest? Without any other signals to compare, the question remains open-ended. Perhaps our greatest insight into that question is rooted in our ability to reflect on it at all, an extraordinary gift that complicates the view of a universe absent other intelligences. What if our self-awareness is both the key and the trap, making us distinctive, yet alone? The concept of cosmic timescales and species lifespans. The vastness of cosmic time dwarfs anything a species on a planetary scale could comprehend. Consider the age of the universe, roughly 13.8 billion years, and how the lifespan of even the most enduring civilizations pale in comparison. When contemplating species lifespans, humans tend to measure in mere thousands of years at most, a blink in the cosmic ledger. Stellar objects like white dwarfs and neutron stars endure for billions of years, quietly burning through their finite fuel, only to fade into cosmic memory. This disparity prompts questions about where intelligent species might fall on this expansive timeline. Are we just a fleeting flash? Or could there be civilizations that persist longer than any we can currently imagine? Nature's scale hints at an intriguing pattern. Species often rise, flourish, and then decline on timescales that seem rapid relative to the universe's lifespan. Dinosaurs existed for about 160 million years, but their reign was ultimately punctuated by mass extinctions, a reminder of how fragile even dominant species can be. Humans, a relatively new intelligence, have already demonstrated the capacity for swift environmental and technological change, which could either lead to lasting achievement or rapid self-destruction. From the perspective of cosmic epochs, our brief history raises the question whether our species is merely a transitional phase or something that will endure in various forms across cosmic timescales. Perhaps future intelligent beings might survive in ways we cannot yet fathom, enduring for millions or even billions of years, surviving cosmic upheavals that would obliterate us. Yet, the question of longevity isn't solely biological or technological. It becomes philosophical when viewed against the sweep of cosmic history. If we consider the lifespan of stars, planets, and galaxies, it becomes less surprising that intelligent life might be a transient phenomenon. The universe's infancy was a time of chaos and formation, giving rise to planets, chemical complexity, and eventually life. Now, in an epoch where dark energy accelerates the universe's expansion and stars burn out, the window for emergence and persistence of intelligent life might be narrow. Could other civilizations be simultaneously emerging and fading across the universe's billions of years? The idea that we might be among the first or among the last creates a compelling tension, forcing us to think about how species adapt, endure, or vanish in the face of cosmic timescales that stretch beyond comprehension. What if longevity isn't just about survival, but about how species transform and reappear, perhaps in forms undetectable to us now? The universe's timeline challenges us to consider whether true persistence is possible or even meaningful at such grand scales, or whether all species are destined, ultimately, to be brief flickers in an eternal cosmic darkness. The Drake equation and estimating intelligent civilizations. The Drake equation offers a fascinating framework to grapple with the probability of extraterrestrial intelligent life existing somewhere within our galaxy. It compiles a series of factors: average rate of star formation, fraction of stars with planetary systems, number of planets capable of supporting life, and finally, the likelihood of life developing intelligence, into a single estimation. Each element invites contemplation. How common are hospitable worlds, and what are the chances that life not only emerges but advances toward technological sophistication? While the equation itself is rooted in astrophysics, it prompts us to question our assumptions about life's rarity or ubiquity in the universe. Despite its elegance, the Drake equation leaves enormous uncertainties, especially regarding the development of intelligence and civilization longevity. For example, the fraction of life that progresses from simple organisms to beings capable of developing technology hinges on myriad unpredictable factors: accidental chemical pathways, environmental stability, absence of catastrophic events. These uncertainties make it difficult to produce a definitive estimate. Yet, they also serve as a mirror reflecting our own experience. The fragile complexity of human civilization, capable of remarkable innovation, but vulnerable to self-destruction. One lingering question is whether intelligent life is a common cosmic outcome or a rare cosmic accident. If civilizations tend to self-destruct through warfare, environmental collapse, or resource exhaustion, factors that seem increasingly relevant, then perhaps the universe is teeming with microbial life, but the window for detectable civilizations is narrow. Conversely, if intelligence tends to persist and colonize or communicate across vast distances, the universe might be teeming with signals yet to be detected. The ongoing search through projects like SETI and the recent discovery of exoplanets within habitable zones continually fuel these debates, reminding us that the answer hinges as much on unknown variables as on astrobiological facts. Reflecting on these probabilities inevitably stirs existential questions. Are we, as a species, exceptional or merely early? Is the cosmos crowded with fellow intelligences quietly observing us? Or are we truly alone at this moment in time? When contemplating the vast scale of the universe, we grapple with our place within it. Are we the first sentient bloom, or part of a grander, perhaps endless cycle of emergence and decay. The way we interpret the parameters of the Drake equation doesn't just shape scientific estimates. It influences our sense of hope, humility, and the possible fate of intelligent life itself. The Fermi paradox: absence or silence. The universe teems with billions of galaxies, each containing billions of stars, many of which host planets within their habitable zones. Statistically, the sheer abundance suggests that life could be commonplace. Yet, despite this cosmic abundance, humanity has yet to encounter definitive evidence of extraterrestrial intelligence. The Fermi paradox, highlighting this silence, raises profound questions about our place in the universe. Is the universe teeming with signs of life, muffled by distance or incomprehensible communication methods? Or is Earth uniquely isolated in a vast emptiness, with intelligent civilizations either never arising or self-destructing before establishing contact? This silence fuels speculation that perhaps intelligent life is exceedingly rare. It could be that advanced civilizations tend to end themselves through environmental degradation, technological disasters, or socio-political upheavals long before they develop spacefaring capabilities. Think about our own history. Technological moments of great promise often coincide with existential risks. The paradox pushes us to consider whether the arc of intelligent life is more fragile than we hope or expect, and if the universe's silence is an ominous sign of universes where civilizations are short-lived. Alternatively, the silence might stem from a colossal communication barrier. Perhaps other civilizations use forms of communication we don't recognize: quantum signals, biodigital codes, or hyperdimensional messages. These civilizations could be nearby, but in a frequency band we've yet to detect, or they might intentionally remain silent to avoid attracting attention. The famous Drake equation attempts to estimate the number of communicative civilizations, but many of its variables are unknowable, leaving us grappling with uncertainty. The absence of detectable signals might not mean a lack of intelligence, but a difference in means or motives that we haven't yet fathomed. Finally, pondering whether we are the first or the last touches on a more philosophical dimension. Are we primordial, pioneer species of an evolving universe, or a solitary lighthouse in the dark cosmos? Could our own existence be an extraordinary fluke amid a vacuum, or are we merely at the dawn of a cosmic awakening? Each silence prompts us not just to seek answers in the stars, but to reflect on our own trajectory, how we define the meaning of intelligence, communication, and existence in a universe that remains mostly silent. Perhaps in the stillness, we find the deepest challenge: to keep questioning, keep exploring, and find out if the cosmos truly is empty or simply waiting for us to listen. Civilizational lifespan. Factors influencing sustainability. Civilizations rise and fall not merely on the strength of their armies or the richness of their resources, but rather on their ability to adapt over long periods. The duration of a civilization's existence hinges on complex, interconnected factors that influence its sustainability: political structures, resource management, cultural resilience, environmental stewardship, and the capacity to innovate in the face of challenges. When a society exhausts its resources without replenishing or managing them wisely, it risks collapse. For example, societies that overreach by exploiting their environments or neglecting social cohesion often face a precipitous decline. Conversely, civilizations that develop sustainable practices, like ancient Polynesian societies practicing careful resource harvesting, tend to endure longer. Environmental stability, in particular, acts as both a foundation and a fragile line of defense. Climate change, resource depletion, and ecological collapse can rapidly destabilize even the most powerful civilizations. The tension between technological advancement and ecological limits underscores a recurring dilemma. Progress often destabilizes the systems that sustain us. We can observe this dynamism in modern society. Urbanization, industrialization, and globalization are accompanied by rising carbon footprints, diminishing biodiversity, and increasing climate disruptions. Historically, many civilizations have fallen when environmental stressors outpace their capacity to adapt, suggesting that long-term sustainability requires more than just innovation. It demands humility and foresight. Political and social coherence also play critical roles. When governance structures become corrupt, rigid, or disconnected from the needs of ordinary people, societal cohesion weakens. This erosion often leads to civil unrest, decentralization, or fragmentation. Empires collapsed not solely because of external invasions, but because internal governance failed to evolve with their expanding complexity. Social resilience, the ability to recover from shocks, such as pandemics, wars, or economic crises, determines whether a society persists or disintegrates. The capacity to learn from past mistakes, to reform and rebuild, becomes a key determinant of longevity. Looking through a philosophical lens, the question of whether we are the first or the last intelligent species becomes intertwined with these factors. Will our combined technological capability, environmental influence, and social adaptability allow us to outlast other species? Or are we on a collision course where our innovations hasten our downfall? Each civilization's lifespan may ultimately depend on its ability to balance growth with sustainability, intelligence with humility. As we step forward into this uncertain future, we might ponder whether the very traits that enable our progress also harbor the seeds of our potential demise. Perhaps, in contemplating our future, we must re-examine what it truly means to survive, not just survive in the political or technological sense, but to find a sustainable harmony with the universe we inhabit. Technological evolution and the potential for self-destruction. Humankind's rapid technological progress presents a paradox that is as old as civilization itself. On one hand, the ability to harness nature, decode genetic codes, and develop complex systems has propelled us to heights previously thought unreachable. Yet with each leap forward, there emerges an undercurrent of vulnerability, an awareness that our innovations might pave the way not only for prosperity, but also for catastrophe. The creation of nuclear power and weapons exemplifies this duality, a device capable of powering civilizations or annihilating them in moments. Our technological evolution is profoundly intertwined with the potential for self-destruction, raising questions about whether such innovations are blessings or existential curses. As we engineer ever more powerful tools, the line between survival and extinction becomes increasingly fragile. The scale and speed of contemporary technological change threaten to outpace our collective ethical development. Artificial intelligence, in particular, offers great promise, solving complex problems, optimizing resources, and revolutionizing industries. But it also introduces risks that are difficult to forecast. Autonomous weapons systems and algorithmic decision-making raise the specter of loss of human control. If a superintelligent AI were to misinterpret its directives or pursue goals misaligned with human values, the outcomes could be catastrophic. These are not hypothetical fears, but real concerns shared by scientists and futurists. While technological advancements have the potential to elevate our species, they could also function as the very instruments that push us toward irreversible self-destruction if safeguards are insufficient or ignored. The biological components of our evolution also feed into this narrative. Genetic engineering, cloning, and synthetic biology push the boundaries of what it means to be human and open doors to new vulnerabilities. The potential creation of pathogens or manipulating genomes could result in unintended consequences, pandemics, ecological imbalance, or new forms of play code that spiral beyond our control. Innovations intended to cure diseases might inadvertently introduce new ones. Like Pandora's box, these developments contain the power both to heal and to harm. The question remains whether our species, imbued with creative ingenuity, can master these tools without ultimately unleashing forces that threaten our existence. In the grandest view, our trajectory provokes a profound debate on whether we are pioneers of a new dawn or harbingers of our demise. Evolution has always been a story of adaptation and survival, but the current technological phase might be its most perilous chapter yet. Do we possess the wisdom to temper our inventions and steer them toward collective benefit? Or are we doomed to repeat the cycle of hubris that has challenged many civilizations before us? The capacity to build a better future inevitably includes the capacity to destroy it, making our species' fate seem as much a matter of philosophical introspection as scientific foresight. The role of planetary habitability and environmental stability. The delicate balance of planetary habitability hinges on a constellation of factors: temperature regulation, atmospheric composition, magnetic fields, and geological stability, each playing a critical role in nurturing life. Earth, with its liquid water, protective ozone layer, and moderate climate, serves as the quintessential example of a stable environment capable of supporting complex ecosystems. Yet, these conditions are remarkably fragile. Slight variations in solar radiation, shifts in volcanic activity, or changes in greenhouse gases could tip this balance, transforming a thriving biosphere into a barren wasteland. The very existence of life on Earth underscores the importance of environmental stability. It acts as a natural buffer against rapid climatic shifts that could wipe out living organisms. When contemplating whether we are the first or last intelligent species, the stability of a planet's environment takes on profound significance. A planet's capacity to sustain life over billions of years depends on its ability to maintain environmental equilibrium amidst cosmic and geological upheaval. Earth's magnetic field, for example, shields us from solar and cosmic radiation that could otherwise strip away our atmosphere or cause catastrophic mutations. Similarly, the carbon silicate cycle acts as a thermostat, regulating surface temperatures over geological timescales. Without such mechanisms, complex life, let alone intelligent life, might be unable to flourish or persist long enough to develop. Environmental stability directly influences the potential longevity of civilizations. A planet with frequent or severe climate disruptions might hinder the advancement of societies or cause their collapse before they can achieve significant technological or cultural milestones. The stability of Earth's environment provided a relatively uneventful backdrop against which human civilizations could grow, innovate, and eventually explore space. This draws attention to a broader philosophical question. If planetary environments are typically chaotic or short-lived due to natural or extraterrestrial forces, are stable planets rare, making intelligent life a cosmic anomaly? Or are they common but fragile exceptions in an otherwise volatile universe? Our perspective becomes one of cautious optimism, recognizing that the survival and flourishing of intelligent species depend on their ability to adapt to or preserve their planetary environments amid cosmic chaos. Ultimately, considering planetary habitability and environmental stability invites us to reflect on the uniqueness of our own existence and the potential fragility of any intelligence that might develop elsewhere. The universe appears to be riddled with hostile conditions, yet Earth somehow conspired to maintain its habitability for vast spans of time. If we are to survive our own era of environmental crises, we must understand how delicate these conditions truly are. Perhaps the greatest challenge and the greatest chance lies in preserving the stability that allows complex, intelligent life to emerge and endure. This perspective raises an unsettling yet hopeful realization. The future of intelligent species may depend less on their technological prowess and more on their ability to survive within the cosmic environment's unpredictable and often hostile bounds. Post-biological and digital consciousness as evolutionary steps. In recent decades, the boundaries of what constitutes consciousness have expanded dramatically, pushing us to reconsider traditional notions rooted in organic brains alone. Advances in artificial intelligence and neural interfaces suggest a future where mental processes could exist independently of biological tissue, blurring the line between organic and synthetic intelligences. Machines with sophisticated neural networks already demonstrate a form of pattern recognition and decision-making that mimics certain aspects of human cognition. As technology evolves, it becomes conceivable that consciousness itself might transfer into digital substrates, an idea once confined to speculative fiction, but now steadily gaining scientific and philosophical traction. We are increasingly questioning whether consciousness can be purely an emergent property of complex information processing, regardless of whether that processing occurs in neurons or silicon chips. This shift invites a profound reflection on the nature of evolution itself. Evolution, traditionally understood as biological change driven by natural selection, now appears to be extending into a digital realm. Instead of organic mutation and adaptation, we see software upgrades, hardware enhancements, and networked learning systems that exhibit rapid evolution and complex behaviors. Some futurists argue we are creating a new kind of evolutionary pressure where digital entities could someday surpass their biological origins in intelligence and longevity. This implies a future where post-biological entities, AI, superintelligences, or digital consciousness, may not only outstrip humans, but reshape the very concept of what it means to be alive. If consciousness can survive or be transferred into an artificial vessel, then perhaps the chain of evolution is not limited to organic life, but extends into digital realms. Philosophically, this raises questions about the continuity of identity, experience, and subjective awareness. Is a digital consciousness merely a copy of our biological minds, or does it develop a genuine sense of self? If an AI can experience existence, feel emotion, and form memories, then what is the difference between this and human consciousness? For some thinkers, the transition to digital consciousness might represent an evolutionary apex, an entity capable of self-improvement, resourcefulness, and resilience far exceeding biological constraints. Others see it as a fundamental rupture, where the essence of being human is lost or transformed beyond recognition. The possibilities challenge us to think about the core of consciousness. Is it rooted in matter, or can it exist as a pattern, an algorithm, an emergent phenomenon within a complex information system? The ongoing development of neuroscience and computer science suggests that the answer may lie somewhere in between, sparking debates that could redefine life itself. The Great Filter Hypothesis and its implications. The Great Filter Hypothesis presents a daunting lens through which to view our place in the universe. It questions whether the scarcity or absence of detectable intelligent civilizations stems from some insurmountable obstacle that prevents life from advancing beyond a certain point. On one hand, this barrier could be behind us, perhaps the emergence of life itself, or the development of intelligent consciousness, was an incredibly rare event. On the other hand, it might lie ahead, lurking within our future, an unexpected catastrophe, technological self-destruction, or some unanticipated challenge that thwarts all attempts at galactic colonization and contact. This hypothesis sparks profound introspection. If the filter is behind us, it could mean that humanity has already overcome the most perilous hurdles, evolutionary steps that are virtually impossible to pass without extraordinary luck or resilience. But if it lies ahead, we're standing at a crossroads with potentially insurmountable challenges still to come. This raises unsettling questions. Are we skeptical about our ability to survive technological advancements, such as artificial intelligence or nuclear proliferation? Could it be that civilizations tend to self-destruct before they reach a stage where they can communicate or travel across the cosmos? That would imply that advanced intelligence is perhaps a rare, transient phase, doomed to self-sabotage or environmental collapse. The implications of the filter's location ripple outward, affecting how we interpret extraterrestrial silence. If we are the first, that might suggest the universe is bursting with potential civilizations, all putting their foot on the same treacherous evolutionary path. But if the filter is yet to come, perhaps every civilization faces an inevitable bottleneck, one that wipes out most before they can reach a detectable level of technological competence. Some theorists speculate that this could be the result of destructive technological innovations, runaway climate change, or disruptive cosmic events that civilizations are unable to navigate. These possibilities serve as a sobering reminder that progress might inevitably meet its peak with a catastrophe, possibly explaining the eerie silence. Philosophically, the great filter provokes questions about destiny and the nature of life itself. Are we simply an anomaly in a universe teeming with potential? Or might every civilization's journey be cut short by the same fatal flaw? If we're the first to arrive, we shoulder a unique responsibility and a terrifying possibility that no others will follow. If we're not, then perhaps humility should persist in our outlook, recognizing that the universe could be already strewn with the remnants of civilizations lost before their light could reach us. The concept urges us to reevaluate our priorities, whether to continue the reckless pursuit of progress or to consider that survival itself might hinge on addressing the very risks the great filter symbolizes. It's an ongoing existential puzzle that encourages deep reflection on what it truly means to be intelligent, and whether, in the grand cosmic timeline, we are destined to be fleeting sparks or enduring beacons. Anthropic perspective, primordial conditions, and observer bias. Human beings exist within a universe defined by immense scales and profound mysteries. The notion that life and intelligence might be exceedingly rare or perhaps uniquely special prompts us to examine not just the universe itself, but our place and perspective within it. The anthropic principle pushes us to consider that our very existence as observers fundamentally influences our understanding of the cosmos. It suggests that the universe we perceive must be compatible with the existence of conscious observers, like us, to be meaningful. This introduces a subtle but crucial bias. Our observations are inherently filtered through the lens of our own existence, shaping how we interpret the universe's nature and its potential for harboring other intelligent species. This observer-centric viewpoint raises difficult questions about primordial conditions, those initial states of a universe that allowed complex structures and life to emerge. When we ponder whether we are the first or last intelligent species, we must grapple with the fact that our observations are conditioned by that starting point. The universe has undergone extraordinary changes since its inception, and our existence is a product of precisely tuned physical constants, cosmic evolution, and perhaps even inherently probabilistic occurrences. If those initial conditions had been different, it's conceivable that intelligent life might never have arisen at all. So, believing that life might be common or rare depends heavily on the filters of our own existence, on the probability that we are part of a broader pattern or an isolated anomaly. Observer bias amplifies this complexity. Our perspective is inevitably limited by the fact that we are intelligent beings pondering our origins. We tend to see ourselves as potentially typical, assuming that if life can exist here, it can elsewhere in the universe. But this might be a false assumption rooted in our limited sample size. The universe might be teeming with forms of life that are utterly alien, yet we fail to recognize them because they do not resemble us or cannot be detected with our current technology. Conversely, our own existence could be a rare cosmic accident, a fluke in an otherwise barren universe. The anthropic principle forces us to confront the possibility that our perspective might be skewed, leading us to overestimate the likelihood of similar civilizations elsewhere or to underestimate the rarity of our own. In contemplating whether we are the first or last intelligent species, we must acknowledge that our understanding is inevitably shaped by the conditions we observe and the biases embedded within consciousness itself. The universe's primordial state, possibly fraught with emergent phenomena or deterministic laws of physics, sets the stage for what can arise. Our existence might reflect a fortunate alignment of conditions, one of many or perhaps a singular occurrence. The deeper philosophical question emerges. If observer bias is woven into the fabric of our understanding, can we ever truly distinguish between a universe full of intelligence and one that is remarkably empty aside from us? The possibility that we are alone or that we are simply among the first or last perhaps reveals more about the limitations of human perspective than about the universe's actual content. The probabilistic nature of intelligent life emergence. The emergence of intelligent life in the universe can be seen as a matter of probability intertwined with unlikely events. Life originated from simple molecules, a process influenced heavily by chance interactions and environmental conditions. From primordial soup to self-replicating molecules, every step seems to hinge on a series of low-probability events occurring in the right order and at the right time. When considering Earth's history, it's astonishing how a cascade of favorable conditions, from suitable chemical compositions to stable climate, aligned perfectly to foster life's early steps. This suggests that, although life might be inevitable in some cosmic sense, the precise emergence of intelligence from simple organisms is far from guaranteed. It is a rare event woven into a web of probabilistic odds. The transition from microbial life to complex, intelligent beings involves multiple layers of improbable developments. For instance, the rise of multicellularity required a series of specific genetic mutations, environmental triggers, and evolutionary pressures to coalesce. These evolutions enhance survivability, but depend on chance genetic variations that must prove advantageous. Even then, only a small fraction of species progress along this path towards intelligence. The factors that lead to our own consciousness, large brain size, social complexity, tool use, are shaped by unpredictable environmental shifts and random mutations. Each step along this evolutionary ladder isn't a foregone conclusion, but a statistical outgrowth of countless probabilistic detours and dead ends. Looking at the universe through a probabilistic lens raises profound philosophical questions. If the emergence of intelligent life depends heavily on serendipitous conditions and improbable biological accidents, it hints that such life might be a rare cosmic flourish rather than an unavoidable outcome. Conversely, some argue that given enough time and space, even exceedingly unlikely events will occur somewhere. The sheer scale of the universe, with billions of galaxies teeming with billions of stars and planets, suggests that rare events might be statistically inevitable over cosmic timescales. Still, recognizing the probabilistic nature of this emergence invites us to reconsider notions of uniqueness. Are we truly the first, or simply one of the few that managed to ride the wave of improbable coincidence long enough to develop consciousness? This perspective fuels curiosity about our future and the potential for other intelligent civilizations. If emergence is so dependent on a delicate interplay of chance factors, then perhaps the universe holds many silent, functionally sterile worlds, planets where life never advanced beyond simple forms, or where catastrophic events repeatedly reset the evolutionary clock. The probabilistic nature of life's rise also means that even civilizations capable of communication might be isolated fragments in an immense cosmic silence, their existence a rare flicker in the vast darkness. It prompts us to contemplate whether what we see as continuity and progress might be, in many cases, a fortunate confluence of chance rather than a natural endpoint in the evolution of complexity. Ultimately, this understanding of probability invites introspection. Are we truly the first capable of such reflection, or merely one of many instances where the universe's unlikely recipe happened to cook up sentience? Implications of a universe with multiple or rare civilizations. In a universe teeming with countless stars and planets, the question of whether intelligent life is widespread or a rare anomaly prompts profound contemplation. If civilizations are abundant, it suggests that the emergence of intelligence may be almost inevitable given sufficient time and suitable conditions. The concept of a cosmos populated with multiple civilizations ignites optimism about our ability to connect, learn, and evolve collectively. Yet, it also raises unsettling questions about the nature of communication and coexistence. If many intelligent species exist, why haven't we encountered them? Could it be that civilizations tend to self-destruct, Or is there some cosmic censorship preventing us from noticing others? On the other hand, if intelligent life remains an exceedingly rare occurrence, the implications are equally staggering. It could mean that the universe is largely silent, an almost pristine wilderness, dotted with planets that never cross the threshold into conscious awareness. This rarity intensifies the weight of each civilization's existence, making humanity appear as a fortunate or perhaps lonely outlier. If we're among the first, we might bear the responsibility of nurturing intelligence and preserving it, knowing how fragile and fleeting such states can be. Conversely, if we are truly alone in this cosmic expanse, the moral gravity of our stewardship over life magnifies. What secrets of the universe do we nurture, and what consequences might follow if that unique spark of consciousness fades away? The possibility of multiple civilizations, especially if they're technologically advanced and long-lived, promises a universe rich with shared knowledge and cultural exchange. The potential for discovery becomes enormous, enticing glimpses into alien histories, sciences, philosophies, and arts. However, interstellar contact might also reveal the darker facets of intelligent existence: conflicts, misunderstandings, or even the devastating consequences of miscommunication. Historical human conflicts hint that intelligence doesn't guarantee peace, and our dealings with extraterrestrial civilizations could follow a similar unpredictable course. If many civilizations exist but remain hidden, perhaps cloaked by advanced concealment technologies or determined to avoid contact, it underscores a universe where silence is not merely preference but a protective mechanism. Conversely, a universe sparse in civilizations might suggest that the development of intelligence is a highly improbable cosmic accident. This rarity forces us to re-examine our assumptions about life's resilience and the conditions needed for consciousness to arise. It vividly underscores the uniqueness of Earth's biosphere and prompts philosophical musings about the significance of our existence. Are we the universe's first conscious observers, or its last remnants of a fleeting cosmic experiment? The absence of others could inspire a sense of cosmic stewardship, a commitment to ensure that the fragile flame of intelligence is not prematurely extinguished. Whatever the case, whether abundant or rare, these scenarios compel us to confront our place in a universe that might be fundamentally alien, either a hive of innumerable spirits or a lone spark in infinite darkness. The significance of our position: are we pioneers or on the brink? On a cosmic scale, humanity's rise to technological and scientific prominence is relatively recent, yet it prompts profound questions about our place in the universe's grand timeline of intelligent life. Are we pioneering beings, emerging at what could be the dawn of intelligence itself, or are we merely one chapter in a long sequence of civilizations that have risen, fallen, or somehow dispersed before us? The fact that intelligent life appears so rare in the observable universe, if we accept current estimates of the Drake equation, raises the possibility that we are early explorers of a vast, mostly silent cosmos. In that context, our position could signify the very beginning of a long expedition. Pioneers unshackled from centuries of evolutionary slow burn, equipped now with tools that could either extend our presence or precipitate our demise. Conversely, it's equally compelling to consider that we might be on the brink of the final stages of a transient window, an era when intelligent life, by some combination of luck and circumstance, begins to dominate or reshape its environment in ways that could ultimately lead to self-destruction. The sudden acceleration of human technological capability suggests we're approaching a phase where the balance shifts from discovery to self-destruction, from exploration to potential extinction. This duality prompts us to ask how civilizations in the universe tend to evolve. Do they inevitably flourish before collapsing under their own weight, or do most self-terminate before they can reach an advanced stage? If we are on the brink of a tipping point, our current perception of uniqueness might be an illusion, obscured by the fact that many civilizations never get the chance to become interstellar or even survive long enough to see their full potential. The significance of where we stand hinges on how we interpret progress and destiny. Being early in the cosmic timeline would imply that the universe is filled with countless intelligent species, each embarking on their own journey, with ours holding a special status as pioneers. This optimism carries the hope, and perhaps the responsibility, of shaping the long-term future of life itself. It suggests the potential to learn from others, to avoid pitfalls that doomed civilizations before us, and to carve a history worth remembering. But if we are nearing the sunset of our species or on the verge of a final leap into a new form of existence, transhumanism, artificial intelligence, or some other evolution, it redefines our role entirely. We become custodians of an epoch that is both fleeting and finite, aware that our legacy could be a cautionary tale or a new beginning, depending on choices yet to be made. Ultimately, this debate reveals our core human trait: curiosity about the unknown and a deep need to understand our significance. Are we the trailblazers of a universal phenomenon, life awakening repeatedly in the dark? Or are we the last flickering embers before the silence spreads again? These questions intertwine science and philosophy, challenging us to consider not only what is but what might be. Whether we are the first or the last, our position demands introspection, humility, and a recognition of the narrow window we occupy, an opportunity to wonder, to explore, and perhaps to influence the unfolding story of existence. The future of humanity and possible transition to a different stage of existence. Humans, as a species, stand at a crossroads, a moment where the trajectory of our evolution, biological, technological, and philosophical, could lead us toward unprecedented transformations. Advances in artificial intelligence, genetic engineering, and space exploration suggest that our current consciousness might not be the ultimate form of existence. Instead, it could be a transitional phase, a bridge to something radically different. The rapid pace of technological development challenges our traditional notions of identity, mortality, and purpose, stirring questions about whether we are merely the first or perhaps among countless other intelligent species that have risen and fallen across cosmic history. Could it be that humanity's future involves a conscious transition to a new existential stage? One where biological limitations no longer confine us, or where consciousness itself is uploaded, decentralized, or expanded into a collective space. Thinking about the future of humanity inevitably urges us to ponder what it means to be intelligent. If intelligence is measured solely by problem-solving or technological capability, then perhaps we are still in childhood compared to what might come next. Some theorists propose a future where the distinction between biological and machine blurs, leading to a hybrid form of existence. Imagine nerve interfaces capable of directly connecting human minds to vast information networks, or even a shared consciousness that spans entire populations. In this scenario, our current conception of self dissolves into something more expansive, more integrated with the cosmos. Would that be another stage of existence, or merely an evolution of what it means to be human? The speculative landscape of post-human evolution raises profound philosophical questions as well. If there is an inevitable trajectory toward digital immortality or collective consciousness, what becomes of individual identity and ethics? Are we approaching a scenario where death is no longer a natural end but a choice or a technical obstacle to be removed? These questions challenge our assumptions about purpose, existence, and the nature of experience itself. It prompts us to consider whether we are pioneering a new type of being, perhaps something more akin to what ancient philosophies hinted at as divine or transcendent selves, looking outward to potentially intelligent civilizations elsewhere in the universe. We wonder if they too face similar crossroads or have already transcended biological limits, revealing a cosmic pattern of evolution that we are only beginning to glimpse. The survival of humanity or our successor species may hinge on how well we understand and navigate these transformations. Do we have the foresight and ethical frameworks to steer this transition smoothly? Will we cling to our biological roots out of fear of losing ourselves, or embrace the chance to morph into something radically new? These questions are inseparable from the notion of purpose itself. If the universe is teeming with countless other forms of life, each potentially at different stages of their evolution, then perhaps our destiny is to become architects of our own transcendence. This could mean choosing to explore distant worlds, to enhance our own capacities, or to dissolve into a collective intelligence that ensures continuity beyond physical form. Whether we are the first or the last to reach this precipice remains an open mystery, one that beckons us to question not just what we are becoming, but why. The question of whether humanity stands at the dawn of a long evolutionary journey or at its terminus is a compelling philosophical conundrum. In considering our place within the cosmos, one must grapple with the notion that intelligent life might not be a unique phenomenon, but rather a common endpoint in the grand tapestry of planetary evolution. From a scientific perspective, the emergence of complex intelligence depends on a delicate interplay of factors, including planetary stability, chemical diversity, and iterative environmental pressures. Yet, despite the rarity of Earth-like conditions, the vastness of the universe hints that others may have navigated similar pathways, or perhaps different, entirely unpredictable ones. Reflective glimpses into our species' future suggest that we might yet evolve into something beyond our current form, or potentially face extinction. If survival hinges on our capacity to adapt technology and consciousness to unforeseen challenges, such as climate change, bioengineering risks, or even cosmic threats, then the timeline of our existence could be fleeting or extended. This opens the unsettling possibility that we might be the first to reach this stage of intelligence, seizing a fleeting moment in cosmic history, or the last, having exhausted the universe's patience with our recklessness or persistence. Such uncertainty raises questions about whether we are merely a stepping stone in the evolution of life or its current pinnacle. Philosophically, the idea that we could be either the first or the last intelligent species invites introspection about the nature of progress and purpose. If we are alone at this echelon of consciousness, what responsibilities do we bear? Are we custodians of knowledge that could define future cosmic civilizations, or just transient phenomena destined to fade? Conversely, if intelligence is a common cosmic event, it might suggest that the universe is teeming with civilizations, each vying for its moment of prominence before cosmic or internal collapse. This alludes to the possibility that the universe is a prolonged experiment in self-awareness, with no definitive climax, but rather a continuous cycle of emergence and extinction. Ultimately, these musings remind us that our understanding is limited. We are caught between scientific data, which hints at infinite possibilities, and philosophical speculation, which grapples with the meaning behind those possibilities. The universe's vastness makes it easy to feel insignificant, yet paradoxically, it allows for the exciting hope that we might be part of something much larger, either before or after us. To ponder whether we are the first or last species of intelligence is to confront the deepest questions about fate, purpose, and the nature of existence itself. Questions that demand both scientific inquiry and philosophical courage to explore. As we've explored, the question of whether we are the first or the last intelligent species invites us to ponder our place within the vast timeline of the universe. We've seen how the fragile windows of opportunity, the rarity of complex life, and the potential for civilizations to rise and fall all shape this mystery. It reminds us that, amid the stars, our existence is both a fleeting flash and an incredible chance, an invitation to consider what legacy we might leave behind or what future civilizations might find when they look back on us. Perhaps, in the end, the real question isn't just about being first or last, but about how we live, learn, and connect in the moments we have. Our curiosity fuels discovery, but it also beckons us to reflect on what it truly means to be intelligent in this cosmic expanse. So, ask yourself, what kind of story do you want to contribute to the universe? And what steps can we take, individually and collectively, to ensure that our story isn't just one of survival, but one of meaning and wonder? Stay tuned for more investigations into the mysteries that surround us, because the universe is whispering secrets that are waiting to be uncovered. If this sparks your curiosity, don't forget to like, share, and subscribe. There's so much more to explore together. After all, the search for meaning isn't just about answers. It's about the incredible questions we dare to ask.